Hello, this is Steve Kimbrough. This presentation is about the Asadai project. The Asadai project is an ongoing R&D project involving a number of collaborators as well as myself, taking place here at the University of Pennsylvania. The project in general is about text mining. Now, text mining is the computerized, automated processing of text in order to extract and derive useful information for decision making. The overarching thing that we're trying to do is to figure out useful ways to convert words into numbers. Numbers are things we know how to use for decision making. We in general, right? But text is much more difficult, much messier, and a bit of a puzzle. So I'm going to tell you about our project and some of the basic ideas by which we're being guided to convert words to numbers. In order to do this, I'm going to discuss three guiding principles that we're working on, and I will also discuss some applications. Now, this presentation is in two parts, so the first part will mainly be the three principles, and the second part will discuss the applications. My goal in both parts is to give a high-level, non-technical briefing so that you have a basic understanding of what the concepts, approaches, the fundamental ideas are by which we approach this project. Now, we have three principles, and we call them concept scoring, concept representation, and categorization. I'm going to discuss each one in turn. It's important to note that I've chosen these and organizing the presentation in the way I am because I expect that the principles are basically familiar to people, and to you in particular, the listener. So I hope so, but we're going to do them, and we do them with a variation, perhaps in some non-standard ways, some standard ways as well. But what we want is the basic idea, and it's these basic principles. And once we have them before us, then the point is that there are variations on them, different kinds, etc. We should think of these principles as building blocks for building interesting applications of text mining. And think of them as bricks, and there are different kinds of bricks, big ones, little ones, etc. So there'll be variations on these concepts, and we will be using these then to build interesting systems. To the principles now. The first principle, concept scoring, I think should be familiar to anyone who's used an internet search engine. Think of what happens. The first thing you do is you put your query into the internet search engine, one word, two words, whatever. And from our point of view, your query is representing a concept. And the thought is this: you have in your mind a certain concept, notion, or idea. You reduce that concept, notion, or idea to a query, one or more words, which you hope will, adequately capture your concept, at least for the purposes at hand. The search engine takes this concept in the form of your query, concept representation really, and returns a list of documents ranked by score. So what the search engine has to do is somehow match your query representing your concept to all these documents that it has access to. And in doing that, for each one, it obtains a numerical score of the degree or relevance of the match, and then it ranks the documents according to most relevant and presents you the results. So normally in an internet search engine, you don't see the scores, you just see the result of sorting the documents on the scores. Now, search engines are called search engines because mostly what they do is search rather than match. And they generally have very primitive, relatively simple matching engines. And that's not what we're doing. We're using much more sophisticated techniques, and we're developing fancier, more subtle ways, basically, to do matching and to get more precise, more informative scores out of the documents. And I will mention, as we'll see coming up, in part two mainly, that there's no reason at all to return just one score per document. So you may have a complex concept that leads to several different scores, and then these have to be put together or maybe used for decision making. So part of what we have is a sophisticated matching engine. second principle is concept representation, and I've already alluded to it, but let's recall. When you use a search engine of some sort, your concept is represented by your query. This is very good. This is fine for lots of simple purposes. If you want to know, for example, is the Porcini restaurant in Philadelphia open on Monday evenings, and do they take American Express cards? Well, you know, this is, I think we can all think of pretty simple, useful queries that will work. However, for many much more serious things, when you want to really get it right and it's much more complicated, an interesting question to ask is, what's the optimal query? Why do you think that for a hard problem you can just kind of wander over to a browser, type in some words that come to mind, and get a good response? Okay, so here are two examples. Suppose instead of looking at all the documents on the web, you had, say, annual reports from all the companies in the Wilshire 5000. And you are interested in ranking these companies and investigating them with respect to their behavior on environmental sustainability. It's just not going to work to type in environmental sustainability and rank the documents. It simply doesn't work, it won't work, and it's kind of thing that can't work. And so one needs a much richer concept representation for the really complex idea of environmental sustainability than just the words environmental sustainability itself. So you know, one needs to find a better representation, and that's in part what we're about. The second example here is one we'll see a little bit discussed in what follows. And suppose that you're a company like, say, DuPont, and you have a product called Tyvek, which is used in lots of things. It wraps houses and makes biohazard suits and so forth. You'd like to find some new uses for it. So, well, how many products out there? Well, it's got to fit in some existing product, the way, you know, a house is a product, etc. And what you'd like to do is take all the products in the world and ask which of those products might possibly have needs or be improved by properties that Tyvek can supply. A tough question, and I put it to you that simply typing in a few words about Tyvek into the best possible internet search engine will not do the job. Okay? So we're developing methods for representing concepts that are much richer than what you can get by a simple list of, you know, the kinds of words that you would get by typing into a search engine. And of course we're developing the matching engine and have developed it so that it can make use of these richer concepts, and the result is a much richer, more informative, more powerful way of scoring documents based upon you know, more accurate concepts. The third principle is categorization. Now, the work on this principle has been largely done by a related project called the AsadaiPrinciplesApplicationsPart1 project. But I would put it to you this way. In general, thinking beings, such as we are, we organize experience by slicing it, dicing it, and putting the pieces into categories. We are forever imposing taxonomies, categorization schemes, etc., roughly the same thing, on our experience in order to organize it. If we didn't do this, then our experience would be, as described in the wonderful words of William James, a boomin', buzzin' confusion. So we got to do this. Our notion on the Asadai project, and in particular on the AsadaiPrinciplesApplicationsPart1 project, has been to do a similar thing, to make a similar move for collections of texts. Documents have lots and lots of amazing information in them, but for us to get this information out, it is often very helpful, very useful to categorize the documents using categorization schemes or taxonomies that have been developed often for other purposes. These taxonomies and so forth implicitly contain an enormous amount of information which can be used for organizing collections of documents and for extracting information from them, which is just the purpose of our project. We in fact have, under the AsadaiPrinciplesApplicationsPart1 project, 2 patents have been awarded for doing this. We've gotten 2 patents, and a 3rd patent is pending. So let's see a little bit about how all of this works. What I'll call the Caesatola process can be thought of schematically as follows. We'll go from left to right with the sense of the arrows. Fundamentally, we have to rely on the documents, the texts, so we get a collection of documents or texts, as indicated at the bottom left-hand corner. We also need to get a taxonomy, categorization scheme, ontology. These are all pretty much similar words in their meanings. And then we also have to have a concept. So part of what I've said is we want richer concepts, interesting taxonomies, and collections of documents. We feed all of these into the matching engine. The matching engine does its work and issues a report of concepts measured by categories. So the concept is what you put in, and the categories are the taxa, or the categories of the classification scheme, or the taxonomy. And you can get scores for each one of these. You can get more than one score if you want that. And so that's basically what it does, and we're going to show you now how this works a little bit more. But first, let's review what we just said, and then we'll go on to part 2. So in this part, I've said that the Asadai project is about text mining. Central to our view in this project are 3 governing principles for constructing building blocks with which we can further construct systems that are interesting and useful. And the 3 principles are concept scoring, that is, matching a concept to a document and producing a number or more than one number that represents association, information, etc. about that concept with respect to that document or collection of documents. Second principle is concept representation, and here the main point has been to say that very simple concept representations that might first come to mind as a couple of words are really not going to do for serious purposes, and much more complex and articulated structures need to be developed, and we're about that. And the third is that key to all of this really is the categorization of the documents in the first place. So we build a categorized document base with your chosen taxonomy or taxonomies. So now the question is, what can we do with these nice building blocks? And that is the subject of part 2. Thank you.